In this tutorial, we'll look at the key terminologies used in Git for version control and source code management. Let's first explore the different classifications of a repository. First, we have bare repository, which is a repository that has been created and doesn't have any working tree. For example, when we create a fresh repository, either in remote or in local repository, it is considered as a bare repository because it does not have any data. Next, we have a local repository. The local repository is created by specific developers so that they can work in an isolated environment or their local machine. And once the work is completed, it can be committed back to the centralized repository or a remote repository. Now, in a remote repository, the data are not stored on a local system. Rather, it is configured at a remote location, which can be accessed by developers to clone, push or pull the changes that were made in the existing code. And finally, we have an upstream repository. The upstream repository is considered as a parent or original repository from where developers can fork the repository. When a repository is cloned, it has a default remote called origin and it points to the repository, which you have forked from GitHub. The sample figure represents a simple workflow of how developers can interact with repositories. First, we have an origin, which we can consider as a remote centralized repository. Then using the git clone command, we can create a local clone of the GitHub repository. And finally, we have upstream, which gets created as a result of invoking git remote at upstream or forking a remote repository. Let's take a closer look at Git terminology from the pointer's perspective. First, we have branch, which allows us to take the original codebase, create a replica of it, make changes, and then submit the changes to be merged into the original codebase. Next, we have master, which is the default name for the first branch, and this is the branch that works as a central branch, where all changes are merged before they are pushed to production. Then, we have head of, which is a pointer to the most recent commit on the current branch that is made by developers. In the sample figure, we can see that head points to the recent changes. Then we have commits, which are the branches, and all these commits are finally merged to the master. Let's look at some Git terminology to better grasp Git's workspace. First, we have Workspace, which we can consider as a name for your local copy of a Git repository. Next, we have Working Tree, which is the current branch in your workspace. This is found in the Git status output. Next, we have Cache, which is a temporary store for all the uncommitted changes. And finally, we have Index, which is the cache where changes are stored before it is committed. In the sample figure, we can see certain commands that show how the transition is made from Workspace to Index, Index to a repository, and repository to the remote. We are also able to see commands like fetch and clone and checkout, which helps you to get the remote repository and bring it to your current workspace. Moreover, we can see that once we have certain commits, which we have made in our code, they need to be pushed to the remote repository. You can pull all the content from the remote back to your workspace by using the pull command. Let's have a look at how Git handles changes internally, as well as some key terminologies. First, we have stash. Stash is considered a cache, which works like a stack. Whenever changes are made, they are stored without committing in the stash. Next, origin, which is the default name given to remote reposition. So, when we specify origin/master, it is considered as the default setting for remote repository and its primary branch. In the sample figure, we can see commands that we can use to transition from one state to another state. Now, there are two essential states, tracked and untracked. Tracked files are files that Git knows about. Untracked files are the files in your working directory that were not in your last snapshot and are not in your staging area. Tracked files are files that were in the last snapshot. They can be unmodified, modified, or staged. Then we have Git ignore, which contains information of all the files that we would like to in the commit. Finally, we have origin/master, which represents a remote repository and the master branch of the remote repository. In conclusion, we will explore some of the essential Git commands. First, we have pull or pull request, which is a GitHub-specific term to let others know of the changes that have been pushed to a branch in a particular repository. Next, we have push, which is used to ensure that after making changes, the developer can commit and push the changes back to the remote repository. Finally, we have merge fetch, which is a term that is used to ensure that we can know the changes that have been pushed to a branch in a particular repository. In the sample figure, we can see that we have origin and local. Local indicates that it is a local repository, and origin represents the origin repository. Remote repository has its own origin/master, and local repository has its own master. So, using the combination of git fetch, git merge, and git pull, we will be able to synchronize master and local repositories.